was the unique problem that you saw that you said, we have to solve, and hadn't been solved before? What was it that spawned Vamp?
Yeah, I think it's still not solved, by the way, but we tried to help there. But no, we did a lot of stuff with e-commerce platforms and content management. Like these architectures were always like a CRM, ERP, CMS, e-commerce, digital asset. You know these big architectures. E-commerce typically was Hybris, Intershop, Demandware, IBM WebSphere Commerce, Oracle ATG, big monolithical Java applications that were also rendering all the front ends, spitting out these template-based UI. And when they were running in production, basically when the shop was open, it was super hard to iterate upon. Because if you needed to create new templates for front end, you basically needed to recompile almost the entire application again, which is like a JVM, like a big thing, especially for bigger international stacks. So how do you kind of slice out little pieces that you can iterate separately from the rest? That's kind of like why we went to microservices, I think, as an industry. Or in the past, it was like SOA, service-oriented architecture, OSGI kind of models, portlets, all that stuff. But then a new complexity is introduced because you're basically building a distributed application, a distributed system. So you need to have service discovery, you need to have tracing, you need to kind of manage all that stuff. So basically providing a management layer that handles the lifecycle management for your e-commerce stack. That's one of the reasons that we kind of started working on Vamp. So how can you do this in a smart way, doing zero downtime upgrading, shifting traffic based on versions. Maybe you want to move your German visitors first to a new front end and observe if this new front end actually behaves as it should, but also increases your revenue if you kind of hope that it will happen. So the second thing is basically everybody had challenges with scaling. If you have these big monoliths and you load balance them like 2, 3, 5, super expensive. And then we would load and stress test the hell out of these things for Black Monday and these scenarios. And every time it would crash again because you could never predict the real volume of traffic. And then, so you, outside of the peaks, you would be over-dimensioned. So you would pay a shitload of money. And then while the peaks were there, you would be under-provisioned and you would still have big issues. So how can you have the application scale in a smart way? Because often the big scaling happens at the front, at the edge of the application, because if a lot of visitors come in, I mean, there's a funnel. There's only so much percentage that starts ordering, and there's only so much percentage that needs to hit your ERP, SAP backend, you know? And if you can scale your front end independently from your backend, that's much smarter. Smarter. So that's scaling based on real load, on real requirements. That's the second kind of pillar that we started working on. We call it the SLA-based scaling. And the third one is everything basically becoming a data-driven validation. What if I change my configuration file? What if I move from a big instance to 5 small instances? What if I move from Google to Amazon? What do we expect that will happen? Can we kind of configure the system to measure these things? Latency, basket value increase. And can we have the system basically only do this for a small segment of visitors? So we reduce blast radius and validate and with enough significance, and then automatically either ramp it up if it works, or move it back if it doesn't work.
It's basically taking a lot of the risk out of it. And like you say, it's brought in elasticity, flexibility, but then de-risked all these tests that normally you would have loved to have tried, but it would have disrupted everything else in your business.
Yeah, if you can even do it. I mean, the truth of the matter is that the real test is in production.